Let's talk about form. Form is the language of why a drawing looks like physical stuff. Why does reality look like reality? And how can we translate the optical phenomenon of what we see with our eye into something that exists on a two-dimensional surface, like this piece of paper here? We're going to start with just a simple sphere. All you got to do is just draw like, maybe a top and a bottom of it. I sometimes like doing this if I'm drawing a bigger sphere, because it's hard to make the whole thing. So you just got this circle to start with, right? And we're going to draw a sort of half, a crescent moon shape going along it, like that. Doesn't have to be perfect. So we're going to label this as our first element of form. Use a different pen for this. This is the terminator. Now I know you're thinking Terminator like the movie. Fun fact, James Cameron, phenomenal artist, who directed Terminator, I think it was an inside joke that he called it Terminator because he came from a rendering school that was very familiar with these ideas. And he went on to do the actual drawing of the Titanic movie. Anyways, I'm off topic. Point is, this Terminator is the result of a light source, which we could also call an incident. And so really it's just some sort of light that's over here. We can tell based on this curve that if we were to draw some sort of Pixar lamp. Hey, remember construction? Oh no, we're still doing it. It's like there's our starting cylinder. And so our light source shoots light down like this. Oh no, I'm getting too excited about drawing a Pixar lamp. Anyways, there's our Pixar lamp, and it's going like this. And our light emanates down like this. So the terminator is just a line that delineates when we have this transition from light into shadow. And it comes from astronomy, so you might hear about like the terminus of the moon, stuff like that. Now, we end up with two areas next door to this. If I was to go along here and, okay. Now I'm really rendering up this little sphere. This area is called the halftone. And it represents where light has hit this surface. Whereas this is the core shadow. Now, as these light particles come down, these are photons of energy that are descending onto this sphere. And you can think of them like snowflakes. And wherever they land, that's the snow on top of your roof, on top of a car, on top of a bush. And that bush, for instance, might block the snow from landing on the ground. And that's where we have the core shadow. So if I just fill this core shadow in, that's like the underside of your, or that's, as you curve around that bush, this is the area in darkness. Now, if we trace these along here, imagine the ground underneath a car where the snow is piled on top of the car, but underneath the car, there's still this like area that's nice and protected, as if it had a little snow thing. And so you end up with this secondary area where the snow lands on the ground over here, but not here because this sphere is blocking it. Killing this poor pen. So this is going to be called our cast shadow. And it represents that idea of something kind of blocking the light. You might see it on something like, uh-oh, I'm going to draw a face. Oh no, it's Oscar drawing faces again. So when you have like the underside of a nose, there's your nose core shadow on this simple triangle representation of a nose, but it's also going to have a cast shadow come down like that. So as these light particles come down, as these photons of energy come down, you can imagine them like our snowflakes. And as this snow falls on the ground, they're actually more like bouncy balls. And so the light hits the ground and it bounces up onto the surface. And it bounces back down, and it bounces back up, and it hits this surface. And it bounces back down, and it hits that, bounces back, until you get to this choke point where it's kind of getting lost under this sphere. Every time one of these photon bounces happens, you end up with a loss of energy. So surface absorbs some energy and reflects some energy. And when we see that reflection come back up, we see it as reflected light. And similarly, when we see this bounce and all this light, it loses some energy, it loses energy, it loses energy, it loses energy. There's sort of atmospheric light coming from everywhere called environment light. This might be stuff reflecting off the walls from this light source back onto the sphere. It might be that this sphere is outside, the light is the sunshine, but the sunshine that is scattering through the atmosphere creates skylight in every direction. And so what we see down here is something sometimes called ambient occlusion or contact shadows. Painters call it contact shadows. 3D people call it ambient occlusion. And it's this representation of how way down here, there's no more skylight blending in. There's no more environment light. And any light that was happening, if it kept having that photonic loss of light, we eventually have a contact shadow. So these are going to be the darkest shadows in your piece. In fact, I might start rendering this up a little more. So I might save my darkest values for the contact shadows of this sphere touching the ground, right? And then I'll go to a lighter blue to represent how this area is. Oh, that's actually still quite dark. The trick with markers is you never actually know how dark they are until they happen. You don't have to use markers. You can use anything you want. I just like markers because, well, art should be fun. Why not play around with a new art supply? So that starts to be this darker area right here, which is our contact shadows. One more maybe. Markers are also nice because you can get a lot. What did I label this one again? Oh yeah. Contact shadows. Ambient occlusion. Now, similarly, I had mentioned that we have reflected light coming back in. There might be skylight coming from this direction, this direction, this direction. And it sort of bounces off the ground and it comes back into this. So you can oftentimes represent this with basically just imagine there's some sort of like small pool of light kind of right around here. And then maybe a little more like right there. Where that has bounced back up, and so although we start having light reflect upward, we're going to have less light maybe right around here, or on the other side here. So this is like reflected light coming back into the surface. Now there are some good ground rules for this. The lightest light in the dark, which would be like this reflected light, will always be darker than the darkest dark in the light. So in other words, our next thing that we're going to look at is a highlight, which might be like right here. So if this core shadow is kind of all over the place, just fading out. It might just be that like around that area, we have this highlight where this hit it. It's fun playing with markers. Yeah, I like markers. And you can see how I'm building this up over time. Such that there's a little more light here. The best teacher for this, by the way, is set up a little still life for yourself and actually look at the lights happening. If you have some sort of like matte sphere, like see how that rendering plays out. So this ends up being like, although this pink here is a darker chunk of the halftone than over here where we have maybe this light fall off, it's still lighter than over here where you have the darkest level of that reflected light. So this highlight, it's important to note that photons function a lot more like bouncy balls or like billiards balls than like something where it's snow. So there's going to be a point on, although this terminator represents where the light hits or doesn't hit, if you imagine a photon hitting this, what area of this sphere does it have to hit to bounce directly into your eyeball as a polarized light ray? And it ends up being up here. So one of the beginner mistakes I caution against is like drawing your highlight right here. The other thing you might be noticing is like some of this slight extra light source right there. And we might render that up by just drawing ourselves a little background line here. So that's our horizon, or the edge of the table perhaps. And I'm trying to just get something in place to demonstrate that concept. Taking the time to actually render the background really helps with this stuff, by the way. Because then you have a different value with which your eye can consider these things. So we got this highlight here, and we also have this slight amount of softening as we get closer to the edge here. Actually, I'm gonna go full pink here. So we have both this highlight along the edge here and this highlight here. And that's where I wanted to talk about rim lights as well. So this we'll call a highlight. Before we talk about rim lights, let's explain why we see rim lights on stuff. So imagine for a second that you have a disco ball. And a disco ball is covered with tiny little mirror planes that are all pointing in different directions. And we're going to start with this first one right here on the front. That mirror is pointing directly towards you. There's something called a normal, which represents a vector pointing out of a flat two-dimensional surface. Welcome to Oscar's art class where you have to learn math. Awful. But so imagine this is pointing directly at you. So this normal, represented by this pen line, is coming right at your eyeball. Whereas if it was pointing like this is about as perpendicular to your line of sight as it gets. The normal is pointing away from us. So this disco ball is covered in little planes that are each pointing in some direction. And as I get closer to the edges here, they start pointing further and further away until eventually you have right here, this one is pointing directly towards you, but the planes of mirror on the sides are going to be pointing basically outward. In other words, eventually these planes curve around the surface to the point where we can no longer see them because they're on the back side of the sphere, right? Now, what if we tried to represent this by saying if it's pointing towards you, you call it, you render it black, and if it's pointing away from you, you render it white. We would have a gradient where this center plane is really, really hard, totally filled up, And then as we get further and further away, it gets softer and softer until eventually we get to these edge faces that are pure white because they're pointing away from us. And so that's our gradient of black to white that we're working with here. Should have chosen a thicker pen for this. So why do we care about this? Well, this is known as the Fresnel effect. I'll spell it because it's French and it'll make you say, hey, that looks like Fresnel. But it's Fresnel. The Fresnel effect states that as something, let me get this right. The perpendicularity of a surface to your line of sight changes the material property of something. So in other words, as something gets more parallel to your line of sight versus more perpendicular to your line of sight, the material properties might be more reflective or more transparent or more matte. Good examples of this. You're standing at a pristine lake and you look across all this water. The water is a beautiful, flat, perfect mirror of the mountain off in the distance. That is because my line of sight, comparative to the plane of that water way off in the distance, they're almost parallel. But as I get closer to the ground, imagine this is pointing, maybe I can do this. Yeah. So imagine as I get close to the ground, this is the water that is pointing directly up. Come on, do it. So this is the normal on the water that is directly by my feet. And so right now, my line of sight is going that way, whereas the normal on this water is pointing straight up. So in other words, perpendicular to my line of sight. So as I get closer to here, if I look straight down, the water at this point is going to be transparent. Whereas when I look off in the distance, and it's basically a surface that's flat to me, it ends up being more reflective. What does this mean? Well, basically, when in doubt, as something is on the planes of something looking away from you, like the side of my face even, make it, just put rim lights on everything. It always looks cool. So that's the last one I want to make sure you guys have is rim lights. This is not every single thing that you are ever going to render. It's not the end all be all of everything regarding form. We haven't talked about what does metal look like versus a matte surface? What does fur look like? What about penumbra, which is this idea that as this light source gets further away from the impact of the shadowing, light rays on this side and light rays on this one blend together, so you end up with this like ghost image on the side of shadows. So there's plenty more to learn, but this is a really good start point. And I want you to keep these in mind on your project, which is how can you do these in a way where you take your basic objects and you render form on multiples into something more interesting, such as a character or a car or a spaceship.